starting the largest U.S. helicopter ever built. Imagine standing beside a helicopter so massive that it towers over buildings, swallows armored vehicles whole, and produces a thunderous roar that can be heard miles away. A machine so large that, even today, decades after it first flew, no helicopter built in the United States has ever surpassed it in size. This is the story of the Sikorsky CH-54 Tarrhe, better known in its civilian form as the S-64 Sky Crane, the largest helicopter ever built in America. But today's story isn't just about its incredible size. It's about what happens every time this giant machine is brought back to life. From the first turn of the starter to the moment its enormous rotor blades begin slicing through the air, starting the CH-54 is a carefully coordinated process that showcases some of the most impressive engineering ever placed inside a helicopter. Let's take a closer look. The giant is born. During the late 1950s and early 1960s, the United States Army faced a growing challenge. Traditional helicopters could carry troops and light cargo, but they struggled with oversized military equipment. Tanks, artillery pieces, radar systems, bridges, and heavy engineering vehicles often had to travel slowly by road. The Army wanted something entirely different. Instead of designing a helicopter around a large cargo cabin, engineers at Sikorsky asked a bold question. What if the helicopter itself became the lifting platform? The answer became the CH-54 Tarrhe. The helicopter was named after Tarrhe, an 18th-century Wyandot Native American chief whose nickname translated to the Crane. The name fit perfectly. Rather than carrying cargo inside a fuselage, the CH-54 was built around a tall skeletal frame that allowed enormous loads to hang underneath the aircraft. This unusual design eliminated unnecessary weight while maximizing lifting capability. It was unlike anything that had ever flown. A helicopter built around power. Everything about the CH-54 was enormous. The aircraft measured approximately 88 feet, 26.8 meters, long. Its 5-blade main rotor stretched 72 feet, 21.95 meters, across. Standing beside it felt less like approaching a helicopter and more like standing next to a flying construction crane. Power came from two Pratt & Whitney T-73 turboshaft engines. Together they produced around 9,600 shaft horsepower, making the CH-54 one of the most powerful helicopters of its era. Despite weighing over 22,000 pounds empty, the aircraft could lift external loads weighing more than 20,000 pounds under favorable conditions. That lifting capacity made it one of the world's greatest heavy-lift helicopters. Why there was no cargo cabin? One of the first things people notice is what's missing. There is almost no fuselage. Instead, a narrow cockpit sits high above long landing gear. Everything below is open space. This wasn't done to save money. It was done to improve efficiency. Bulky equipment could be lifted directly beneath the helicopter without needing to fit through doors or ramps. The crew simply hovered over the cargo, attached it, and flew away. Vehicles, generators, artillery, boats, shipping containers, bulldozers, even damaged aircraft could all be transported this way. For certain missions, Sikorsky also developed detachable cargo pods that could carry troops or medical patients beneath the helicopter. Preparing for startup. Starting a helicopter, this large, is nothing like starting a car. Before any engine is turned, crews perform a long series of inspections. Fuel levels are checked. Hydraulic systems are inspected. Rotor blades are examined for damage. Transmission oil levels are verified. Electrical systems are tested. Landing gear components are inspected. Control linkages are checked. Because every major system depends on every other system functioning correctly, skipping even a single inspection could jeopardize the mission. Only after these checks are completed does the crew climb into the cockpit. Inside the cockpit reflects the technology of its time. Instead of large digital displays, pilots face rows of analog gauges. Engine instruments, torque indicators, rotor RPM gauges, hydraulic pressure, fuel flow, oil temperature, electrical meters. Hundreds of switches and circuit breakers surround the crew. Every gauge tells part of the helicopter's story. Every needle must move exactly as expected. The pilots know these instruments so well that even a small abnormal indication immediately attracts attention. Bringing the giant to life. The start sequence begins with electrical power. Battery systems or external ground power energize the aircraft. Critical warning lights illuminate. Systems perform self-checks. Next comes the auxiliary power unit, or external start equipment, depending on the operating configuration. Compressed air begins spinning the first engine. At first, only a faint mechanical whine can be heard. Then the compressor accelerates. Fuel is introduced at the proper engine speed. Ignition begins. Suddenly, the engine comes alive. Exhaust gases roar from the turbine. Temperatures rise rapidly. Pilots monitor every gauge carefully. Too much temperature could damage the engine. Too little acceleration could indicate a failed start. When the engine reaches stable idle speed, oil pressure stabilizes. Hydraulic pressure begins building. Electrical generators come online. Only after confirming that every reading is normal does the crew move on to the second engine. The entire process repeats. Now, both engines are running, but the helicopter still hasn't moved. Waking the rotor system, the rotor blades remain almost motionless. Then the transmission begins transferring power. Slowly, almost imperceptibly. The 5 enormous blades begin rotating. At first they appear individually, then they accelerate. Soon the blades blur together into a giant spinning disc over 70 feet wide. The sound changes dramatically. A deep, rhythmic pulse fills the air. The vibration settles into a smooth, powerful hum. This is one of the most recognizable sounds in aviation. As rotor RPM reaches operating speed, pilots perform additional system checks. Flight controls move through their full range. Hydraulic pressures remain stable. Engine power remains balanced. Rotor speed is verified. Everything must be perfect before takeoff. Tarrhe. Precision. Despite its size, although enormous, the CH-54 is surprisingly precise. Pilots often compare flying it to balancing on a tightrope. Heavy lift missions demand exceptional control. The aircraft may hover only a few feet above workers connecting cargo. Sometimes visibility beneath the helicopter is limited. To solve this problem, many CH-54s include a downward-facing crew position that allows another crew member to guide the pilot during load attachment. Communication between crew members is constant. Every movement must be smooth. Sudden inputs could cause the suspended load to swing dangerously. Vietnam. The Sky Crane goes to war. The CH-54 became famous during the Vietnam War. Its lifting ability proved invaluable. One of its most important jobs involved recovering damaged helicopters. Rather than destroying downed aircraft or leaving them behind, the CH-54 could lift them directly from jungles and battlefields. Hundreds of helicopters, including UH-1 Hueys and AH-1 Cobras, were recovered this way. The Army saved millions of dollars by repairing these aircraft instead of replacing them. The Sky Crane also transported artillery pieces, engineering equipment, ammunition, bulldozers, bridge sections, radar systems, and construction materials into areas unreachable by trucks. Its contribution to military logistics was enormous. Lifting the impossible, the CH-54 performed missions that seemed almost unbelievable. It carried mobile hospitals, large communication towers, construction equipment, shipping containers, entire military vehicles. In some operations, it even transported prefabricated buildings. Few helicopters before or since have demonstrated such versatility. From military service to civilian legend. As military needs changed, many CH-54 helicopters left Army service. Instead of disappearing, they began a second career. Their civilian counterpart, the Sikorsky CH-54 Sky Crane, became one of the world's premier heavy-lift helicopters. Today, operators use them for construction, power line installation, logging, disaster relief, and one of their most famous roles, fighting wildfires. Firefighting giant, modern S-64. Sky Cranes carry large water tanks that can hold roughly 2,650 gallons, about 10,000 litres, of water or fire retardant. The tanks can be refilled rapidly from lakes, rivers, or portable reservoirs. Within minutes, the helicopter can return to the fire line. Its precision allows pilots to drop water exactly where firefighters need it most. Every wildfire season, these aircraft continue protecting communities across several countries. Why it still matters. Many helicopters have entered service since the CH-54 first flew in 1962. Technology has advanced dramatically. Cockpits have become digital, engines have become more efficient. Composite materials have reduced weight, yet the basic concept behind the Sky Crane remains unmatched. Its open-frame design is still one of the most effective solutions for carrying oversized external loads. That is why upgraded S-64 helicopters continue flying today. The legacy of America's largest helicopter. The CH-54 never became famous because it was fast. It never became famous because it was heavily armed. It became legendary because it could accomplish missions no other American helicopter could perform. It lifted the impossible. Recovered priceless aircraft, built infrastructure, supported soldiers, protected firefighters, and proved that sometimes removing everything unnecessary creates the most capable machine of all. Conclusion. Watching the largest helicopter ever built in the United States come to life is unforgettable. The slow ignition of its massive engines, the gradual acceleration of its enormous rotor blades, the powerful vibration spreading through the air, and finally, the moment when tens of thousands of pounds effortlessly rise into the sky. The Sikorsky CH-54 Tarrhe remains a masterpiece of American aerospace engineering. More than 60 years after its first flight, its design continues to inspire heavy-lift aviation around the world. It stands as a reminder that true engineering greatness isn't measured only by speed or firepower, but by solving problems that once seemed impossible. And every time this giant starts its engines, it reminds the world why it remains the largest helicopter ever built in the United States.